Assalamu alaikum. Unit 1 Electricity, Chapter 5 Generators and Receivers. Hello dear students. In the previous video we have reviewed some basic electrical principles. In this video we will complete our revision with a physical quantity that you've already known last year. Let us now recall ohmic conductors or resistors. The resistor, an ohmic conductor, is a dipole which completely transforms the electrical energy into thermal heat energy. The types of the commonly used resistors are miniaturized resistors, fill-form resistors, rheostat or variable resistors. Resistors are characterized by a physical quantity called electrical resistance R. The symbol of the resistor in the electric circuit is given by this symbol or this one. The SI unit of the resistance R is the ohm denoted by the following symbol. The resistance R of a resistor is measured using a multimeter functioning as an ohm meter. The two terminals of the resistor are identical. The electrical resistance represents the property of the resistor in opposing the passage of electric charges, which constitutes the electric current. You can notice in the figure, in the presence of a resistor, this resistor resists or reduces the flow of electric current through the wire. Now, what could be the mathematical relationship between U, R, and I? If R is constant, the higher the voltage, the higher the current, then I and U are directly proportional. If U is constant, the higher the resistance, the lower the current traversing the circuit, then R and I are inversely proportional. Then we can write that I equal to U over R, which implies that U equal R times I. Ohm's law states that the voltage UAB across the terminals of a resistor of resistance R is directly proportional to the current I traversing it, which can be written as UAB is equal to R times I, where U is the voltage across the terminal of the resistor, I is the current traversing the resistor, and R is the resistance of this resistor. To study the UI characteristic curve of a resistor, we need to build up the following circuit. In the circuit, you need a variable generator, a resistor of resistance R, a voltmeter to measure the voltage across the resistor, and an ammeter to measure the current traversing it. Each time you vary the value of the voltage, you need to measure the intensity of the current traversing the resistor and record them in the following table. After that, you are going to plot the VI characteristic curve of a resistor. The UI characteristic curve of a resistor is an increasing straight line passing through the origin of equation Y equal AX. By comparison, Y is the voltage across the terminal of the resistor and X is the current traversing the resistor, where A is the slope of this curve, calculated by delta U divided by delta I, which is the resistance of the resistor. Then, for such curve, the slope of the curve represents the resistance of the resistor. Now our final idea is about grouping the resistors in series and in parallel. In series grouping, the resistance R equivalent to R1, R2, Rn is given by R equivalent is equal to R1 plus R2 plus R3. Whereas in parallel grouping, the resistance R equivalent to R1, R2, and Rn is given by 1 over R equivalent is equal to 1 over R1 plus 1 over R2 plus 1 over R3. In the case of only two resistors, the formula can be reduced to the following form. R equivalent is equal to R1, R2 divided by R1 plus R2. Now, dear students, you need to refer to your agenda to solve the exercises chosen from your book as an application. Also, please visit the link in the attached folder to solve the quiz, and notice that Your result will be checked by your teacher. Thanks for listening. See you soon.